This is Mrs. Dawson. 2 real solutions. Solve x squared minus x minus 12 equals 0 by graphing. In order to graph this quadratic equation, it's nice to have the axis of symmetry. So the equation for the axis of symmetry is x equals the opposite of b divided by twice a. In this case, the b value is -1, so the opposite of -1 would be 1, and the value for a is 1. So 2 times 1 gives us 2. So the axis of symmetry for this parabola is at the vertical line of x equals 1/2. So at x equals 1/2, we'll put a vertical line. Now let's go ahead and put 1/2 in the table and evaluate f of x at 1/2. The square of 1/2 is 1/4. We'll do that out here. Minus 1/2 minus 12. So 1/4 minus 1/2 minus 12 is -12 and 1/4. That gives us the vertex of this parabola. The scale on the vertical axis, or f of x, will go by 2's. So this is -2, -4, -6, -8, -10, -12, and we just want to go a fourth. And the x value was at positive 1/2. So here is the point for the vertex of our parabola at 1/2, -12, and 1/4. We'll need several other points for the parabola. So how about x is -4? The square of -4 is 16, minus -4 is the same as adding 4, and then subtract 12. So we have 20 minus 12, which is 8. Let's plot that point. So -4 on the x, 1, 2, 3, 4, and 8 on the f of x, 2, 4, 6, 8. Now the nice thing about having the axis of symmetry is that we can double check our points, and we'll go the exact same distance to the red line from the left and move the same distance from the red line to the right. We'll get some more points later. Another x value, x is -3, square 3, subtract a -3, which is the same as adding 3, and then subtract 12. So when x is -3, f of x is 0. -1, 2, 3. So we found an x-intercept. How about when x is positive 4? Square 4, subtract 4, and then subtract 12. So 16 minus 4 minus 12 gives us 0. So at x is 4, 1, 2, 3, 4, we have the other y-intercept. Or excuse me, x-intercept. Now, notice that these are the exact same distance, 1, 2, 3.5 units, 1, 2, 3.5 units from the axis of symmetry. One more point. How about x is 5? So we're square 5, subtract 5, and subtract 12. So 25 minus 5 minus 12 is 8. X is 5, 1, 2, 3, 4, 5, and y is 8, 2, 4, 6, 8. And once again, you'll see we have a reflection. The exact same number of units to the red line from here as here. So we really only needed to find this point and then plot a partner point the same distance from the axis of symmetry. So now we have 5 points to connect, and we want a nice smooth curve or parabola that passes through all 5 points. Arrows on the end to show that it continues on. Now that we've graphed the parabola, we can solve by finding the x-intercepts, or zeros. So if you take a look, the x-intercepts, or zeros, are right here. That is where x is equal to -3 and x is equal to 4. And we can check that by seeing that we got 0 for f of x when we substitute in -3 and +4. These are the solutions of the quadratic equation.